All right. Today we shall be taking some top JEE chemistry questions. So let's take the first one, which says, on combustion, 0.210 gram of organic compound contain carbon, hydrogen, and oxygen, which gives 0.127 gram of water and 0.307 gram carbon dioxide. The percentage of hydrogen and oxygen in the given organic compound, respectively, are mass of the compound is given as mass of the compound, organic compound, is given as 0.210 gram. Now, mass of water is given as 0.127 gram. Mind you, hydrogen is gotten from water. So in this case, to find the mass of hydrogen, we say hydrogen, mass of hydrogen, molecule over water, times the mass of water, which is given as 2 over 18. 2 times 2 plus 16 times 0.127. Yeah, that gives us the mass of hydrogen. So calculating that, we have 2 times 0.127 divided by 18. This gives us 0.0141 gram. Now, to calculate the mass of carbon in water, carbon in carbon 4 oxide, we said the relative atomic mass, this gives us 12 over carbon dioxide, which is 24, which is 44. How did we get 24? That's 12 plus 16 times 2 gives us 24 times the mass of carbon dioxide, which is 0.307. Using our calculator, we have that as 12 times 0.307 divided by 44. That gives us 0.084 gram. So this is the mass of hydrogen, mass of carbon. So by the time we find the sum together, this gives us the mass of carbon and hydrogen. All right, sum these together, we have plus 0.0141, okay, which gives us 0.098 gram. So this is the mass of both hydrogen and carbon. So for us to find the mass of oxygen, therefore, we'll minus the entire compound, which is 0.210 minus 0.098 gram, which gives us, all right, minus 0.210. Answer. The answer gives us mass of oxygen, therefore gives us 0.112 gram mass of oxygen. Now, the question says, find the percentage of hydrogen and oxygen in the respective organic compound. So giving us the mass of oxygen and mass of hydrogen to be this. To find the percentage, therefore, percentage hydrogen will be mass of hydrogen over the mass of the entire compound. Mass of compound times 100%, which gives us mass of hydrogen to be what? 0.0141 over 0.210 times 100. Yes, somebody help us. That gives us 112. That gives us 1.41. 1.41 divided by 2. Sorry. 1.1412 divided by 0.21. So this gives us 5%. 5% hydrogen. Now, percentage of oxygen, therefore, oxygen, that gives us mass of oxygen all over mass of compound times 100%. This gives us mass. Our mass of oxygen is 0.01, 0.112 all over the mass of the compound, which is 0.210 times 100, which gives us, in this case, we have 11.22 all over 0.2. So 11.2 divided by 0.210, which gives us 53. So that gives us 53% oxygen. The next question says, mass of magnesium required to produce 220 ml of hydrogen gas at STP on reaction with excess dilute HCl. You have to write equation of reaction for this. Magnesium reacts with HCl to liberate hydrogen. So we're giving you magnesium chloride plus hydrogen gas. So when you balance the equation, you have 2 here. So in this case, we are looking for the mass of magnesium that will be produced when you have a volume of 220 ml. So looking at this equation, 1 mole of magnesium is equivalent to 1 mole of hydrogen. So we now have to find the number of mole of hydrogen. Number of mole of hydrogen can be calculated. Number of mole of hydrogen equals 220 over the Avogadro constant. You know, at 1 mole, hydrogen occupies 2 to 400 ml. So in that case, finding the number of mole, divide 220 divided by 22,500 gives you 0.0098 moles. So since we say 1 mole of hydrogen is equivalent to 1 mole of magnesium, automatically they have the same number of mole. Number of mole, therefore number of moles of magnesium equals 0.00. They are the same, 0.098 mole. Therefore, mass of magnesium equals molar mass of relative atomic mass of magnesium, relative atomic mass times the mass. So relative atomic mass times number of moles, which is what? 24 times 0.0098. Somebody with a good calculator should help us. Times 24, which gives us 2, 3, 4 grams. So that will be the mass of magnesium liberated when 220 ml of hydrogen is liberated. All right. The next question says 10 ml of a 2 molar sodium hydroxide solution is added to 20 ml of a 1 molar HCl solution kept in a beaker. Now we take 10 ml of this mixture is poured into a volumetric flask of 100 ml containing 2 moles of HCl and made the volume up to the mark with distilled water. The solution in this flask is that if we want to find the number of moles of the solution in this flask. Initially, we have dilution formula. Our dilution formula states formula that is CV, C1 is equivalent to C2, V2. In this case, we have the concentration of the sodium hydroxide we have, which is 2 times 10, gives us 20 times 1. You can see this one cancel out because you give you all the same 20, 20. So this is not important. But looking at the solution again, this mixture, 10 ml of this mixture was added to a volumetric flask containing 100 ml. So look at the volume. So in this case, fast forward, in this case, the volume of the solution is 100, which is V1, containing 2 mole. So the concentration is 2 mole, 2 times 100 equals the same solution, 10 ml. What's the volume is 10 ml. The concentration is unknown. Let's say X times 10 ml. In this case, solving for X will give you 2 times, this is 200 over 10, which is giving you 20 ml. The question says 10 raised to a minus 9 grams each of the following elements, which is lead, polonium, praseodymium, and platinum. 10 raised to a minus 9 grams each of them. Which one will have the highest number of atoms? And from Avogadro's constant, we have 1 mole of any element contains 6.02 times 10 raised to power 23 atoms. That's 1 mole. So how do you find number of mole? Number of mole, therefore, number of mole equals mass given all over relative atomic mass of each element. So to find the number of mole, so in this case, we have been given lead, which is 204, relative atomic polonium, which is 208, then praseodymium, which is 141. This will be given to you. Then we have platinum. Platinum should be 148 thereabout. I'm not 149. Please let somebody confirm. So in this case, it tells you that the atom with the smallest value of relative atomic mass will have the highest number of moles. And the number of moles determine the number of elements present. In this case, we have, for platinum, we have 10 raised to power minus 9 over 204. Will give you the number of moles. This will give you 10 raised to power minus 9 over 208. Then for this, we have 10 raised to power minus 9 over 141. While platinum, 10 raised to power minus 9 over 149. In this case, if you look at this element, has the lowest relative atomic, all right, relative atomic number, mass for this 195, sorry, 195. Now, in this case, for us to find the number of mole of each of these elements, the atom with the smallest relative atomic mass will give you the highest number of atom. So in this case, 141, which is praseodymium, will give the highest number of atom in this group of elements: lead, polonium, praseodymium, and platinum. So the correct answer will be praseodymium, which is this. The next question says, consider the above reaction. What mass of calcium chloride will be formed if 250 ml of 0.7 molar HCl react with 1000 of calcium carbonate? Mind you, if you look at this equation of reaction, we have 1 mole of calcium carbonate gives you 1 mole of calcium chloride. At the same time, we have 2 mole HCl is equivalent to 1 mole of calcium chloride. So we have to find the number of mole of calcium chloride before we can find the mass. How do we find the number of mole? Since we have 2 mole of HCl reacting with what? 1 mole, we have from the equation, we have 2 moles HCl equivalent to 1 mole C calcium chloride. So how do we calculate number of mole? Number of mole equals concentration, that is C times volume over 1000. In that case, we have the concentration to be what? 0.7.76 times volume, which is what? 250 over 1000. In that case, the number of mole gives us this one gives you 4. So 0.76 over 4 gives us 0.19 moles HCl. So if we say 2 mole of HCl gives us 1 mole calcium chloride, therefore number of mole calcium chloride equals 0.19 over 2. Yes, divide by 2, which gives us 0.095 mole. So for us to calculate the mass of calcium chloride, therefore, will be what? Mass of calcium chloride times number of moles, which will give us mass of calcium chloride. We have calcium chloride, which gives us 40 plus 35.5 times 2. Yes, somebody can help us with that. That is 70 plus 40. Yes, 70 plus 40, that should be 110, right? 70, 71, okay, 71 plus 70 plus 40, that'll be 1, sorry, please help me. 40 plus 70, 111, that's 111 gram. Answer. So now for us to find the mass, therefore bring this one down. For us to find the mass of calcium chloride, that gives you 111 gram times 0.095. Yes, times 111, which gives us 10.5. The answer gives us 10.5 gram. Answer, correct answer. All right. So that's the mass of calcium chloride that will be what? Produced. Okay, the next question says, on complete combustion, 1 gram of an organic compound gave 1.46 gram of CO2. So meaning mass of CO2, 1.46 gram CO2. Then 0.567 gram water. Now, find the empirical formula of compound X. Mind you, we have the elements present in the compound are carbon, hydrogen, and oxygen. So that sum of 1 gram. So for us to find the mass of hydrogen in this and the mass of carbon in this, we have to find, hydrogen. In this case, we were looking for carbon. Mass of carbon now gives us 12/44, which is the relative atomic times this mass, 1.46. In this case, for us to find hydrogen, mass of hydrogen will give us, because we have 2 atoms of hydrogen, that gives us 2/18, which is 2 plus 16, 18, times the mass, 0.567. So solving that, we have 12 times 1.46 divided by 44. That gives us 0.398. Why this gives us 2 times 2 multiplied by 0.567 divided by 18. This gives us 0.0663 gram. Mind you, the sum of this gives us 1 gram. Everything gives us 1 gram. The element present gives us 1 gram. So for us to find the mass of oxygen, we have to sum this together. So summing this together gives us 0.063 plus 0.398, which gives us 0.461. So 0.461 take away minus. So X, therefore, to find the mass of oxygen equals 1 minus 0.461, which is equivalent to minus 1, which gives us 0.539. This is the mass of oxygen. So for us to find the empirical formula of this, we have to find the mole ratio of each. In this case, the mass of carbon dioxide, the mass of carbon here is mass of carbon 0.398 over 12. The mole ratio of this, which gives us what? Hydrogen, which is 0.063 over 1. Then this, mass of this, which is what? 0.539 over oxygen. And you know oxygen is 16. So solving this, we have 0.398, 0.398 divided by 12. This gives us 0.063 0.033. Okay? In this case, this gives us over 1 gives us 0.063. Why in this case we have 0.539 divided by 16. This gives us 0.03336 or approximately 334. So in this case, you divide by the smallest, which is 0.33. This one gives us 0.33, 0.033, 0.033. So dividing this one gives us 1, this one gives you 2, this one gives you 1. So the empirical formula therefore gives you carbon will be 1, hydrogen will be 2, while oxygen will be what? 1. So the empirical formula gives you CH2, CH20, CH2O, which is the empirical formula. Okay, the next question says, choose the correct statement. Of all these statements, which of them is correct, or which of these statements are correct? Weight of a substance is the amount of matter present in it. No. Mass is a force exerted by gravity on an object. No. Volume is the amount of space occupied by a substance. Yes. The amount of space occupied by a substance. Now, D. Temperature below 0 degrees Celsius are possible. Yes, we can have -6, -7, -0.5 and things, okay? In Celsius scale. But in Kelvin scale, negative temperature is not possible, correct? Then the last one says precision. Precision refers to the closeness of various measurements for the same quantity, correct? Precision is simply the ability to reproduce exact measurement in their order, of closeness, the degree of closeness of this measurement, So, of all these, we have C is correct, D is correct, and E is correct. We have 3 statements there that are correct, but the first two, 1, 2 are not correct. Okay, the next question says, concentrated nitric acid is labeled as 75% by mass. The volume in ml of the solution which contains 30 grams of nitric acid is, what will be the volume of nitric acid that will contain 30 grams? What will be the volume of the solution that will contain 30 grams? So, given the density of the solution to be what? 1.25. So let's put down the parameter. We say we have density. Density of nitric acid equals 1.25 gram per mil. Now, we have the concentrated acid labeled as 75% by mass. By mass. Contains 30 grams nitric acid. So in this case, this can be interpreted as, let's say, let mass of substance or solute be M. In that case, we have 75% M equals 30 grams. Hello? We mean 35% of mass M contain 30 grams, which means we can have 75%, meaning we can have 0.75. If you convert this percentage, that will give you 0.75 M equals 30 grams or 30. So M, therefore, will give you 30 to find the mass now over 75, 0.5, 0.75. Yes, can somebody help us with that? So that gives us 30 divided by 0.75. That gives us 40 grams. So the mass of the substance is going to give us 40 grams. Mind you, we have density of a substance. The density of the acid is 1.25 grams per mole. So if we have 1.25 grams per mole, automatically we can have the density, if we want to convert it from mole to 1000 cm³ or the L, that gives us, or to approximately we have one, if you multiply this, we have 250 grams per dm³. That gives us the density. Is that clear? So we have the mass of the substance containing 1250 grams per dm³. In that case, how do we find the mass? You say, the question says the volume in ml of the solution which contains 30 grams of nitric acid. So since we have density equals mass over volume, therefore volume, if we cross multiply, volume becomes mass over density. So in this case, we have the mass, which is 40, all over density. Density, which is what? 1.25. So looking for this, to find the volume, yes, somebody help us with the calculator. (40) by 1.25, which is the density, equals 32. So the volume becomes 32 ml. Correct answer. Okay. The next question says, the elemental composition of a compound is 54% carbon, 9.2% hydrogen, and 3.6% oxygen. If the molar mass of the compound is 132 grams per mole, the molecular formula of the compound is given as, mind you know, empirical formula multiplied by N gives us the molar mass, which is equivalent to the molecular formula. So in this case, we have to first of all determine the empirical formula of the element present. We have carbon, hydrogen, and oxygen. So determining the empirical formula of this, we have to find the mole ratio of every element present. So in this case, we have carbon 54% over 12. For hydrogen, we have 9.2 over 1. While for oxygen, we have 36.6% over 16, which is their relative atomic mass. So finding this, okay, let's use our calculator. We have 54 over 12 divided by 12 gives us 4.5 mole. Then this one gives us 9.2. While 36 divided by 36.6 divided by 16 gives us 2.29. Now, divide both sides by the smallest ratio. This gives you 2.29, 2.29, 2.29. So in this case, we have 4.5 divided by 2.29, which is a 1.9, approximately 2. Why this gives us 9.2. 2 divided by 2.29. This gives us 4. Why this one gives us 1? 2.22. So we have the empirical formula as C2H4 O, that is oxygen. Now, mind you, empirical formula multiplied by N gives us the molar mass, which has been given as 132. 32. So in this case, summing all this together, we have 12 times 2 plus 1 times 4 plus 16 bracket N gives you 132. In this case, this gives you 24. 24 plus 4 plus 16. This is 20 plus, that's 46 equals 132. 46 equals 132. N, 46 N equals, so therefore N will give you 132 divided by 46. 132 divided by 46. The answer is 3, approximately 3. So in this case, the molecular formula, if we bring this one here, the molecular formula, therefore, where Cn, C2, H4, N, where N equals, our N has been calculated to be 3 now, will give us C6, H12, O3. Answer. That is the molecular formula of the compound, C6H12O3. All right, the next question says, combustion of glucose, that is with the formula C6H12O6, produces CO2 and water. The amount of oxygen in gram required for complete combustion of 900 grams of glucose is, in this case, we have to write equation of reaction. We have glucose, H12O6, will be burned or combust to give you CO2 and water. You know, so writing the balance equation, you have to balance the equation in this case. Okay, we have 12, so 6. Okay, carbon 6. So for carbon and hydrogen is balanced. So how about the oxygen? Oxygen has to be, we have 6 oxygen here and 12 oxygen here. So automatically we have 18 oxygen. So in this case, we have 9 here. Okay, the equation is balanced. So the question again says, combustion of glucose produces CO2 and water. The amount of oxygen in gram, we're looking for this oxygen in gram, that will be required for complete combustion of 900 grams of this. All right. In this case, we have to find the number of mole. 1 mole of oxygen gives you 9 mole of oxygen. You know? So in this case, what is the number of mole of glucose? To find the number of mole of glucose, number of mole, glucose will be mass all over relative molecular mass of glucose, which is 900 grams over relative molecular mass of glucose is 180. Let's confirm. Confirm that. That is 12 times 6. 12 times 6. A good student should be able to help us. That's 72. 72 plus 12 plus 16 times 16 times 6. That's 96 plus 12 plus 12 plus 72. 72. That means I'm correct. So 180. So find the number of mole. That gives us 900 divided by 180. 180. That gives us 5. 5 mole. Okay? So in this case, we have 1 mole from the equation reaction. 1 mole glucose requires 9 mole oxygen. So how many moles? Therefore, 5 mole glucose will require X moles of oxygen. Therefore, X, number of mole of oxygen, gives us 5 times 9, which will give us 5 times 9, that gives us 45. 45 moles. So, to find the amount of oxygen in gram, oxygen, 1 mole of oxygen, 1 mole. Since 1 mole of oxygen gas equals 32 grams. Therefore, 45 mole oxygen, 45 mole oxygen will give us 45 times 32, which will give us 45 times 32, will give us 1,440 grams. 1,440 grams answer. Correct answer. All right, question 13, and this is going to be the last question for today. It says the number of moles of methane required to produce 11 grams of CO2 after complete combustion is, combustion of methane. Methane is taken as CH4 plus oxygen, gives you CO2 plus water. You need to balance the equation. So balancing the equation will give you, this is hydrogen, 4, so 2. How about oxygen? Oxygen has become 6 in this case. So we have, this is 2 plus, that is, so oxygen becomes 2 here. So we mean 1 mole of methane reacts with 2 mole of oxygen. But the question says we should calculate the number of mole of methane required to produce 11 grams. Number of mole. We're looking for number of mole of methane. Number of mole that will give 11 grams of this. So in this case, we have 1 mole of methane. 1 mole methane equivalent to 1 mole CO2. So number of mole of CO2, number of mole, therefore, mass of CO2 all over molar mass. So we have 11 all over 44. 44 is the relative atomic molecular mass of CO2. So in this case, we have 11 over 11 divided by 44, which is 0.25. 0.25 mole. So since 1 mole of CO2 is equivalent to 1 mole of since 1 mole of methane is equivalent to 1 mole of CO2, therefore, number of mole of methane is equal to 0.25 moles. Answer. So we have come to the end of the question and answer for JEE for today. Please don't forget to like and subscribe so that when we have new videos like this on our channel, we can get in touch with you.
Hi, I'm sure you enjoyed the video you've just watched. To see more of this kind of content across all examinations, including WAEC, JAMB, JUPEP, GACAO, NITs, SAT, IIT, literally up to 100 exams, make sure you hit the subscribe button and check the channels for all of these videos and tutorials.